Hello and welcome back to Particleworks Power-Ups. In today's episode, we're tackling a request from a transmission design engineer, but it's one that we hear from many Particleworks users. If you've ever needed to calculate power losses in a transmission, you'll want to stick around for this one. By default, Particleworks calculates forces and torque of fluid interactions with rotating parts. But what if you need the power losses to determine transmission efficiency? It's a simple calculation, but when you've got a system with lots of gears and variable RPM, it can quickly become time-consuming. That's why today we're developing a macro that does the hard work for you. This tool will automatically calculate power losses for every component in your simulation, and even let you plot the results directly in the Particleworks GUI. Let's get started. We start by importing the required Python libraries like pandas, shutil, and of course the Particleworks Python interface. We connect to the active session and grab the current scene, just your standard initialization. This time, we're also capturing the project object because we'll need to access the results directory. Once we've defined that path, we create a backup folder to keep the original talk files safe, just in case the files go missing or get corrupted. Next, we prepare a handy dictionary to map axis names like X, Y, or Z onto their numeric index. We'll use this later when calculating the power. Now for the core loop. We go through every polygon node in the scene. These represent the physical parts in your simulation that produce torque data. For each one, we print out its name. Note that Particleworks will remove the file extension from the node name, which we can do using rsplit. Back up the torque CSV file, and load that file into a pandas data frame. Then, we loop through each time step in the file, and for every column that contains torque data, we first update the object's motion to match the time of that row, read its current angular velocity. This means RPM can be variable and the power calculation will always be accurate. Finally, calculate the power by multiplying torque by the rotational speed of the correct axis. Insert this new power value into a corresponding column in the data frame. Once we've done that for all the rows and torque columns, we overwrite the original CSV with this new one, now including the power data. By overwriting the file, we can then access these new columns within the graph and overlay tools within the Particleworks GUI. We then move on to the next node and the cycle begins again. That's it, our macro is complete, so let's test it out and see it in action. Here we've got a simple gearbox simulation. If we open the graph tool, we can see force and torque data available for each gear, but there's no sign of any power data just yet. To run the macro, all we need to do is drag and drop the script directly onto the scene viewer. As it runs, we see each polygon node printed in the console as the macro processes it. That's the power being calculated in real time. Once the script completes, we jump back into our graph tool. Now alongside each torque column, we've got a new power column, ready to be plotted and analysed. Just note that Particleworks isn't aware of the units of this new column, but we can update the axis titles by updating the axis properties. It's quick, easy and saves you time having to calculate the power by hand. If you have a problem you'd like our help with, our contact details are on screen now and in the description below. For more information about our full API online training course, visit our contact page for details. See you next time.